all clean and stuff. Okay, this is Humpty Dumpty worksheet, so it's stuff about falling, right? When things fall, what happens to that object? Yes, I go down. And Kennedy, say that again? It accelerates, good. So it's gonna get faster as it goes. And do we know the rate at which it accelerates? Lewis?
9.8.
Good. So we say little g, that's the acceleration of gravity, is equal to, and you might say negative 9.8 meters per second squared. If you want to do for your problems, if you want to round that to 10, that's totally fine with me. If you want to just make this 10 and then it's easier to just do it in your head, that's totally fine. I won't, you can even do it on a test for me. Doesn't bother me at all. Is that the same for any object? Yes, it's the same. Is it the same in real life? Melody's shaking her head and so is Emerelli. What's the difference in real life?
Air drag.
Air drag, yeah, there's air resistance in real life, but in physics 11 there's no air, so we don't have to worry about that. Everything accelerates at the same rate. Izzy, even if it's heavier, does it accelerate still at 9.8?
Yeah.
Yeah?
Once it reaches, what's it called?
What's it called?
Constant. No, not constant.
Okay, you're talking about terminal velocity.
Yeah, that one.
Is this the terminal velocity?
No.
No. But I'm glad you brought it up, because if you drop something, like if I threw this pumpkin out of an airplane, it would be bad. But eventually it would fall and it would accelerate at this rate, right? But eventually it would be falling so fast that the air resistance would be so great that it would stop accelerating, right?
Does it start at that and then it...
In real life, yes. In real life it starts at this and it goes to, Kennedy? He said it. 0. Yeah, it goes to 0 acceleration, so it just travels constant velocity. But that's in the real world. We're not in the real world. We're in physics 11, where there's no air. So if there's no air, it always accelerates at 9.8, and it never reaches constant velocity. So Izzy, is this constant velocity?
Yeah. No. No, it's not.
No.
That's gravity.
This is the acceleration of gravity. Everybody write that down. G equals negative 9.8. This is the acceleration of gravity. So in grade 11, we want to start with the basics. We don't want to talk about air resistance. So we assume everything accelerates at 9.8 all the time. Okay. We know it's a little bit different than the real world. I don't have the worksheet anymore.
It's right here.
Oh, thank you. Put it down on this desk. Okay, number 1D we're gonna do, because that's what this class asked for. So how far had Humpty fallen when it reached, oh, we're calling Humpty it. That's sort of sad.
What's Humpty, an egg?
Humpty is an egg, yeah. What would you call an egg?
But what egg is it?
They call him
He?
in the song.
That's really weird that an egg is a he.
Well, you just said it's
Because an egg can only come from a female.
No, but what egg is it? What animal's egg?
But people can only come from females too. It's like a chicken.
It's a chicken.
That's so deep.
Wait,
You're
what?
right about
What's
that.
feet?
Yeah.
What's feet?
Did you know that your mitochondrial DNA is only from your mother?
Yeah.
Because everything other than your one half of DNA is from your mom.
What?
It makes me angry because I want my daughter to be more of me, but she's actually more of my wife.
You can't control that.
She has my eyes though. She looks a lot like me. I'll take it. This problem says Humpty Dumpty is dropped into a very deep wishing well. We'll make it so that he's falling forever. Oh, sorry, he's not falling forever. He hits the water 4 seconds later. So here's the well, and Humpty is this egg.
You should draw eyes. Yeah.
I think we should at least call Humpty they.
Yeah, they is.
That would be more respectful than it. It always bothers me when people call babies it. You know, oh, your baby's so cute. What's its name? She's not it.
I would do that.
4 seconds later, so Humpty falls, and there's water at the bottom. Oh yeah, I appreciate that. Thanks for noticing. And time equals 4 seconds. So Humpty hits the water 4 seconds later.
Why is it happy when it's falling?
Why is it happy?
Yeah.
Well, it's like an egg's mission in life. Get to the water. I don't know. Here's the thing about falling stuff. There's always something you know that's not necessarily told to you. Okay, so you're told it took 4 seconds to fall. There's 2 other things that we know, but we have not been told. What are those 2 things? Kennedy, say that again. Good, so the acceleration is negative 9.8. Now, you have a choice here. We can make down positive, or we can make down negative.
Negative.
Who would make down negative? Because it's too confusing, and down is always negative. Okay, who would make down positive in this case? Wow, more in this class said positive. So that's a rational thing to do. You can make down positive as long as you keep it positive all the time. And if there's any upward movement,
That's negative.
then that has to become negative.
Because it's going down and down is negative. It's just why would you make positive?
So for in your mind, you keep this negative and you make this negative, and your displacement will be negative as well. In the rest of your minds who put your hand up, I know what you're thinking. You're thinking everything is down. Let's just make it positive because I hate negative signs, right? So if that's your mind, totally fine. We'll make this, because more people put their hand up, we'll make down positive and up is negative. I'll do it for you negative if you want to. So in that case, this is plus 9.8. There's another thing that we know that we have not been told. The initial velocity is what? Turn to the person beside you and tell them what the VI is.
It's VI. VI and VI.
VI is VI. That's not a thing.
I so feel so exhibition.
You can't just say VI is VI.
Me?
Yeah, that's a cheat thing.
Okay.
Melody. I know you want me to leave you alone, but
I can hurt this too. It's 0.
thank you so much.
I definitely.
Good job. So VI is 0. So we have A and we have VI and we have T. And number 1, D says we're looking for how far it had fallen when it reached,
So velocity time.
oh, how far had Humpty fallen when it reached negative 25? So we have been told something else, actually. I didn't realize that. So we've been told that VF equals 25. Now, if you made down negative, this would be negative 25. If you make down positive, you have to change this to positive 25. So this T equals 4 seconds, that's actually not part of our question for this. Because it's just asking how far you've gone when you're traveling 25 down. So that's somewhere in here before we hit the water. If that was confusing, I'm sorry about that. Okay, and we're looking for D. All right, how are we gonna solve that? Which formula would you use? Yeah, I would choose the second formula. Turn to the person beside you and tell them why these variables would lead you to use the second formula.
Because of the variable on there fits on that. Yeah, because we like it. Yeah,
Jaya, tell me.
The first one's thinking
And you have all the variables, so you can just lump it in.
Yeah, that's absolutely right. So Jay is saying that these 4 variables are in the second formula, which is BF squared equals BF squared plus 2AD. So we just have to rearrange this for D now, right? So what we're gonna do is subtract my VI squared, and then I'm gonna be left with 2AD. So how do I get rid of the 2 and the A? I'm gonna divide them over here. If this takes you more steps, that's totally fine. But you're gonna get to this place, and that's gonna equal displacement. And then after that, it's just filling in the numbers. You can literally just punch them in your calculators. But I will write them out. So you're gonna go 25 squared minus 0 squared, which is just 0. And then over 2 times 9.8. If you're a down is negative person, then this is going to be negative, and that's also going to be negative, but it's going to disappear because of the square, and you're going to end up with a negative displacement, which is right if you made that negative. But we did. So 25 squared is 625, I think, over 20, so that's like 15, 16? 16?
31.
What? I love that you think that's so funny. Oh yeah, right. 625 divided by 20. No, that's not right. Is it?
31.8.
25 squared is 625 divided by 2 divided by 9.8. Huh, 32.
Yeah.
Yeah, I guess that makes sense. Divided by 10 would be 62. So around 31 or 32, is it?
Yeah.
32, I'll say. Pretty close to 32 meters. So what is that telling us? What does this answer tell us?
It's at 32 meters down one.
At this place, at 32 meters down from the beginning, you will be traveling 25 meters per second downwards. Okay. Good? No? What do you mean?
Can you do it in negative, please?
It was just negative 32.
Yes, of course I can. If you do it negative, then this will be negative, and that will also be negative, okay? And so when you, the formula is all the same, but then this will be negative like that. The negative will disappear because you're squaring it.
Okay.
But this is also negative. So if your down is negative, then your displacement will also be negative, which is fine. It's just 32 meters down from where he started. Okay? Okay, that's 1D. Let's do 1G then. And the G says, draw rough DT versus V, D versus T, and V versus D graphs of Humpty's motion. Okay, so let's do that. Do you want to make the down negative or positive for the graphs?
And the graphs?
Who would make the graphs negative? And who would make the graphs positive? Wow, you guys are all positive people. Okay.
That's a nice thing. We're all
Yeah.
positive.
Well, let's do both. Here's if down is positive, and here's if down is negative. So if down is negative, you're gonna have to have your T, your 0 would be up here. And it says DT and VT, right? So you only have to do one of these, but I'll do them both. So as you fall, what happens to your velocity? It's growing, right? So if you think down is positive, you're going to draw a line like that, straight. So it's changing velocity, and it's changing at a constant rate. If you're thinking down is negative, it looks like this. Okay, so as Humpty falls, or anything falls, what happens to the displacement covered from second to second? It's increasing, right? You start off like this, and then you cover more, and then you cover more, and more, and more. So this one has to be curved. If you're thinking down is positive, it's going to curve up like that. And if you're thinking down is negative, it's going to curve down like that. It can look a little bit different, but the displacement has to be curved and the velocity has to be straight. If I said to draw me the AT graph for this, what would that look like? Yeah, it would be flat, right? And this would be positive 9.8 for you positive people. And this would be negative 9.8 if you're thinking down is negative. Okay. That's 1D and G. Let's switch back now. Okay, so 2C, that's 2. Oh, 2 is Samurai Jack. So Samurai Jack has a ninja doll, and he throws him straight up. How do you draw a samurai person? It's kind of like something like that, isn't it? Yeah, and a big sword. So Samurai Jack has a ninja doll, and he throws the ninja doll up in the air. So this is now motion in two directions, right? There's upward motion and there's downward motion. So I'm assuming most of you would make up positive and down is negative. Is that good?
Yep.
Good with that? Okay.
Which question is this? 2C?
Yeah, 2C. So Samurai Jack throws it up, and the only thing we're told is that the VI is, what does it say? 30 meters per second. Now some of you are going to stop and go, when you throw something, the initial velocity is 0. Because I'm holding this right here and I'm about to throw it and it's not moving. So isn't the VI 0? Turn to the person beside you and explain why the initial velocity of the throw is not 0. Serena. Good. So Kennedy says, while it's in my hand, I have to accelerate it up, but then it's gonna leave my hand, right? So as soon as it leaves your hand, that's really the initial velocity of the flight of the object. And that's all we're concerned about in Physics 11. We're not concerned with the time that it's in your hand. We're only concerned with the time that it's flying up and coming back down. So the VI is positive, 30. What else do we know that we have not been told? Gravity is, this time we've said down is negative, so this has to be negative 9.8. Right? So we know A and we know VI. And it says for C, what 2 times is the doll 25 meters above the ground? So we're going to say he goes up some height, it must be more than 25, but it says at 25 meters, when is he there? Okay, so what you need to do first, the first step is to find the final velocities. And you might be thinking, well, how is there 2 different times when he's in the same place? So let's find out. So step 1 is to find the VF. So if we know A and we know D and we know VI, and we're looking for VF, this is D, by the way, which formula are we going to use? the second one again. So we have this one. And we really just have to get rid of this square to find the final velocity. So how do we get rid of a square? We're going to square root both sides. Okay, so VF is equal to this. Now there's something about a square root mathematically. What is that thing that you have to remember about a square root? Good. It can be a positive answer or it can be a negative answer. Like for example, what's the square root of 9? 3. So 3 times 3 is 9, right? What is negative 3 times negative 3? Also 9. So the answer to a square root is really plus or minus whatever you come out to here. Your calculator will only tell you the positive answer. You have to remember that it can also be negative. Okay, so what's the answer? So we put in square root of 30 squared, so that's 900, plus 2 times negative 9.8, and this is 25. And you're gonna have 900 minus 24 is 500. So 400, so 220, 20, is that the answer? Let's find out. 20.2? Thank you. Because of the 9.8, right? Okay, so we have plus 20.2, as Hawk says, and it could also be minus 20.2. Turn the person beside you and explain why these two velocities can be different. How can you have two different velocities? Jessica, tell me. No? You're doing the right thing. You're like,
Going up, and it reaches 0, and it goes negative.
perfect, very good. Let's have a golf clap for Jessica. So I'm embarrassed a little bit. You can have two velocities because it goes through this place twice. On the way up, you're going to be going 20 meters per second upwards. And on the way down, you're going to be going 20 meters per second downwards. So negative 20, right? So that's why you have two separate velocities. As soon as you get those two separate velocities, then it's easy to find the times, right? We can plug them into our original formula and solve for time. So we're going to subtract our VI, and we're left with AT, and then we divide by the A, and that's going to give us time. So our VF, first of all, is 20. So we're going to do 20.2 minus 30 was our original, and we're going to put that over at negative 9.8, and that's going to be about 1 second, I think.
Yeah.
A little bit less? 1.02? Thank you so much. I'm just going to say 1.0 seconds. That's on the way up. And then on the way down, you're going to say negative 20.2 minus 30 over negative 9.8. And that's going to be somewhere around 5 seconds, I think. Is that right? Yeah, 5.1 or so. So there's actually 2 times when the doll is at that place. Once on the way up, and then it goes up and stops, and then comes back down, and then it's at that place again in 5.1 seconds. So that's the trick with that one. It's a good question, whoever brought that one up. That was 2C, right? Oof. What is the doll's VAV and SAV for the entire flight? Well, I'll tell you, the average velocity is going to be 0. Why? Yeah, because if I throw something up and then it comes back down and I catch it, what's the displacement of this? 0. It's back where it started, right? So the velocity is 0. The average speed for the whole flight, now we have to find out how high it went because we need the total distance if we're going to get speed. Okay, so this is, how long has the video gone for? Is it still working? I know, if it's too long then, I know I might do part 1 and part 2 because it doesn't load to YouTube very nicely. Oh yeah, 25 minutes, my goodness.